So in this lesson we want to take a little look at output under the Turing system. And because the output commands that we need to know are fairly straightforward, we're also going to take a look at how you do some mathematical or some arithmetic calculations. What I've got here is I've got a Turing file, and I've already put a whole bunch of comments in it, and they're just going to explain what we do as we go along. So we're going to start up at the top and work our way through here. I've got my header, some output notes. In this file I've called output_lesson.t, and of course I'm the one doing the lesson here. So first off, to output something on the screen, we use the put command. First example here is just a literal or a string, closed and quotes. So if we want to output something to the screen, we type the command put, and we can do something like hello there. And if we run this, hello there pops up on the screen. If we want to do more than one thing, we can put another put command here. Let's say we want to put hello there student. So put student as a second string. Student. And then we run this. Okay, it says hello there student. So by default, the output goes on to a second line there. If we want to get that output to stay on the same line, we put two dots at the end of it. So if I put two dots at the end of this line and then I run this again, I get hello there, and then it stays on the same line, so it doesn't clear the line and go on to another one, and then it puts student right after that. So we can use this to format our output a little bit. We could do something like put my, and if I want to do more than one string on the same line, I just put a comma in between them. So my first string is my next string is name, I can do another one is, and if I do two dots, that is going to keep it on the same line there, and then I can put an actual name in here. We'll use the name Alan. So this is going to output my name is Alan, and it's all in the same line. There it is, my name is Alan. So notice that there are no spaces in there. If we want this spaced out nicely, we have to actually put these spaces into our individual strings or individual literals. And then if we run it again, it's all nice and spaced out. My name is Alan. Alright. So that's basically output. Now to do a little bit more on output, we're going to look at how you do calculations, or you do arithmetic operations here in Turing. So I'm just going to uncomment all of this stuff using Control 5. And here are the basic operations. Okay, first thing we want to let's just run this to see what this looks like here. All of these are all in the same line because I put dots on the end of them. So what we're going to do is this line here is going to put 1 plus 2 equals onto the screen, and then we're going to do this next line that is going to output the result of that, doing that calculation. So if I just do put 1 plus 2, okay, with no quotations around it, Turing will carry out that mathematical calculation, 1 plus 2, and output the result. If I hit F2, I can space that out a little bit nicer. Same thing with 7 minus 4. If I do put 7 minus 4, okay, or multiplication, put 10. Now for multiplication, we want to use the asterisk here, or the star, to do multiplication. If we want to do exponents, we do 2 stars, so this is going to be 4 star star 2. And if we want to do square roots, we put the command to do a square root is actually a function that we'll talk about later in this course. We do sqrt, so that does the square root, and in brackets we put the number that we want to take the square root of, so 36. So now if I run this, well, I'll hit F2 first to space it out all nicely, and then if I hit run this, I get all of these calculations carried out. 1 plus 1 equals, and then it outputs the answer. 7 minus 4 equals, and then this second line here does the calculation and outputs it. Now, it's not enough just to do these calculations. We often want to control the spacing of this output. So we can do this by using sort of two numbers that follow our output after semicolon, after a colon here. So here I've got put the square root of 40 is colon 5. Let's just run this. So this puts The square root of 40 is, and this colon 5 after the colon 5 makes the is take up 5 spaces. Now you only need 2 spaces for the is, because it just has 2 characters in it. So what happens is when it does the output, it pads an additional 3 spaces on the end of it. So it does is and then 1, 2, 3 blank spaces before it does our colon here. Okay? So I've made the point right here. For strings, spaces are added at the end. Now for numbers, it'll add numbers on at the beginning if it doesn't have enough space. So let's say we want to output the answer of the square root of 40. We want to put sqrt square root of 40. If we just do this like this and we run it, okay, it outputs the answer here, 6.324555. By default, it does 6 decimal places there. Let's add a number after this colon here. We'll do colon 10. Okay, that's going to make that number, the square root of 40, take up 10 spaces. So let's run this again. And see, notice, we've got 1, 2, 3, 4, 5, 6, 7, 8, and then it pads 9, 10 blank, 2 additional blank spaces to make sure this thing takes up the 10 spaces that we've told it to. For strings, spaces are added at the end, as we saw with the is. For numbers, they are added before the number. Okay. So that first number there is called the field width. If we add another colon and then another number, we can specify how many decimal places this thing is going to take up. So if I do colon 2 like that, that takes my 6.32455, and if I run this again, now it only outputs 2 decimal places. Notice that because now it only takes up 1, 2, 3, 4 characters, the 6.32, it's padded a bunch of other spaces out in front here in order to keep this nice and the required 10 spaces. Here. And there are other ways of formatting our output. Okay. We can also use, if we want to do some spacing, we can also use what's called a tab. So if I wanted to get this put to be slid over a little bit, if I do a /t inside there, that inserts a tab into that string. So if I run this now, it's added that tab in there to slide over the square root. I'm going to take that out. Okay, and run it again. Okay, second number is the number of decimal places. Okay, division. Now division is kind of complicated in computers. There is several different kinds of division here. First, we can do straight division. 5 divided by 2 equals, let's output this calculation, 5 divided by 2. So we just use a simple slash there for division. If I run this, 5 divided by 2 equals 2.5. There's also what's called integer division. If I do 5 div 2, well, let's carry out this calculation here, 5 div 2, and I run it, div 2, the div command, returns the integer, the integer closest to the result here. So 5 div 2, instead of 2.5, it returns the integer part of that 2. If I had done, let's say, 10 div 3, okay, and I run this, it returns 3. Well, it says 5 div 2, but let's change this. 10 div 3 here is 3. And if I do, instead of the 10.33 and so on. So it rounds it off to the nearest digit. The next kind of division here is what is called modulus division, which returns the remainder. So the remainder when 5 is divided by 2 is, we do 5, and what we use is the percent symbol. Sorry, what we use is the mod, the word mod here in between them. 5 mod 2 returns the remainder. So if we do 5 divided by 2, we get 2.5. The integer part of that is the 2. The remainder is 0.5. The remainder there is that it goes in evenly twice, and we have 1 left over, so the remainder is 1. Okay. And finally, we can round off our numbers if we want. Okay, if we've got a number like 2.6, we can round this off by just using the command round. 2.6. So if I round 2.6, oh, that's giving me an error there. Why is that giving me an error? Because I'm not outputting this. So put round 2.6. There we go. 2.6 gets rounded off to 3. And the round works exactly like you would expect. It takes your decimal, rounds it off to the nearest integer. If you're so 0.6 gets rounded up to 3. And if I were instead had 2.1 and I do put round 2.1, it's going to round that down to 2, rounding off to the nearest integer. Now we can force it to round up or to round down using two different commands. So if we've got 3.8 and we want to round down to the nearest integer, we can do put what is called the floor command. Okay, floor is down at the bottom, so this is going to round this down. So if we do floor 3.8, this is going to round this down to the nearest integer. Rounding down, 3.8 gets rounded down to 3. Or we can force it to round up. Just like floor rounds down, if we do the ceiling, or seal, okay, 3.1, this will round it up to the nearest integer. So the nearest integer above 3.1 is 4, so this will output. If I run this, 3.1 is rounded up to 4. And that should get you going on output.